In this video, we will review section 17 and 18. Section 17, couple little directions here. We're going to simplify these 5 problems. Then we're going to take this function and evaluate f of 5. Then we're going to take this function, evaluate g of 3, and find its domain. So all of that is section 17. And then section 18, we are going to use rational exponents to simplify this group. We're going to rewrite this using radical notation. And then we are simply going to evaluate these 3 values. So, going back to 17, let's jump in. Simplify, this is the square root. Well, 81 is 9 squared, so 9 squared x squared, the squares cancel, and we're just left with 9x. Number 2, square root again. This time it's 100x to the 6th. 100 is 10 squared. The x to the 6th is not as easy. Some people would break it down like we've seen as x cubed squared. The squares cancel. I'm left with 10x cubed. But even though this is section 17, this is where some people can take advantage of the rational exponents, that instead of doing this one this way, the 100 is 10 squared, we should do that one in that straightforward way. But for the second part, the square root is the 1/2 power, x to the 6th to the 1/2. That's an alternative way to get your x cubed. Number 3, well, now it's a cube root. So everything needs to be a perfect cube. A is cubed, that's perfect. 64 is 4 cubed, as perfect as can be. The cube root of 4 cubed a cubed will just be 4a. Number 4, the cube root of negative 125 x to the 12th, well, starts nice. Negative 125 is a perfect cube. Just don't lose the negative here. That stays. So we'll get a negative 5 when I take the cube root of negative 5 cubed. And then here with the variable, it's not as clean as what we were seeing here. So I could think hard about it. How can I write x to the 12th as something cubed? And I'll come up with x to the 4 cubed. Cube root and cube cancel. I'd finish with minus 5x to the 4th. But I'm going to keep saying it, the alternative that a lot of people like, the cube root of x to the 12th, I'll do that part as x to the 12th to the 1/3 power. Use that rational exponent. 12 times 1/3 is 4. There's my x to the 4. Number 5. Now it's a 4th root. Hey, that's perfect. What about the 16? Well, if I just do a little arithmetic, I'll figure out it is also a perfect 2 to the 4th power. So this will just be a nice 2x. The function notation, how am I going to find f of 5? Well, on the left side, the x gets replaced with 5 as notation. The right side, I actually do the arithmetic. Inside my cube root, 6 times 5 is 30. 30 minus 3 is 27. So I have the cube root of 27. 27 is a perfect cube. So I finish with a final answer of 3. Same idea here. Now I'm looking at this function. Evaluate g of 3. Plugging 3 in for x. Just to be a little careful again here, 2 times 3 is 6. So I'm getting 10 minus 6. That's a 4. And the square root of 4 is a clean 2. But how about the domain of g? Again, these two, you know your function notation. You just plugging in and doing arithmetic. But domain doesn't give you any of those hints. to realize that, okay, the whole key is I can't have a negative under a square root. There is no domain issue with cube roots, by the way. All that whole that we could have a cube root of a negative and it stays negative, there is no domain issues here. You'll notice they never ask about domain of cube roots because there's no domain issue, but the book has several domain of square roots. Under the square root must be greater than or equal to 0. Well, solving that, isolating my x, I got minus 2x is greater than or equal to negative 10. I'm dividing by a negative 2. The fact that I divided by a negative, my inequality sign flipped to a less than or equal to 5. 5 is the key value. We're looking for everything less than or equal to that. So that would be negative infinity up to 5. 5 included, 5 gets the bracket. And now section 18. Again, section 17 has more guidance. Section 18 feels a little wish-washy, just following the directions. Use your rational exponents. Okay, rational exponents, 16x to the 12th to the 1/4 power. Well, now that I have that as an exponent, I can distribute that. What is 16 to the 1/4? What is x to the 12th to the 1/4? Well, the 16 to the 1/4, we realize that is the 4th root of 16, kind of going backwards, and that comes out as a clean 2. X to the 12th to the 1/4, I multiply that out, and I get an x cubed. Over here, well, again, first thing, rational exponents. The 4th root of x is x to the 1/4. The cube root is x to the 1/3. I'm multiplying. In order to multiply, I will add those exponents. Common denominator will be 12. I'd multiply this one by a 3, this one by a 4, so I will finish with 7/12, or x to the 7/12 power. Funny thing here, a lot of people, once you start doing this work with exponents, and again, for a lot of us, dealing with fractions is not as easy as dealing with nice, clean, whole numbers. So doing a little work off on the side, but then the bad habit, people just say, well, their answer is 7/12. No. Remember, that was just the exponent. The answer is still x to the 7/12, not just 7/12. Number 3, the square root of x is x to the 1/2. Here, this is where it's great if you could do it in one shot. That'll be x to the 2/3. So we've seen putting two exponents together, radical to the denominator, regular exponent to the numerator. But no problem if you went a little slow like we did here. Now you multiply, 2 times 1/3 gets you to 2/3. Now I'm dividing, so I will subtract the exponents. minus 2/3. This will become a 3/6. This will become a 4/6. So I will end up with x to the negative 1/6. And that's where we more traditionally move that negative exponent to the denominator, 1 over x to the positive 1/6. A quick reminder, that word simplify, our exponent rules still hold. We still don't like negative exponents. So getting a negative exponent like that, part of simplifying would be getting it back to a positive. Now I jump here, rewrite using radical notation. Well, I've got the 1/5 power, so going backwards, 1/5 will be the 5th root of 9x cubed y. The last 3, evaluate, deal with these exponents. And some people, from what I showed them, now they're going to the calculator for this, but it's really a good habit of just using the calculator maybe as a check and getting used to going back and forth, using these as necessary. What am I going to do with the 1/2 power? I'm going to think of it as a square root. And once I look at that as a square root, hey, 81 is 9 squared. That's a clean 9. Similar here, but first thing, the negative exponent, I'm going to shoot it to the denominator to make it a positive, but then 100 to the 1/2 will be the square root of 100, so I will finish with 1/10. Last one here, the 2 components, either the cube root of 27 squared or cube root of 27 quantity squared. 27 squared is a big number, so let's make our lives easy. Let's do the radical part first. The cube root of 27 is 3. The squared is still there, and then 3 squared is 9.